Hello my dear students, welcome back to our channel Deeksha Karnataka. Today I'm here with your another very important class in the series of Masterstroke. Okay, I'll cater to everything for both PU2 as well as your KCET, and the chapter is the highest weighted chapter across your syllabus, Continuity and Differentiability. Now you're thinking, sir, what about integrals? Yes, that also is there, but this is also equally important, and again this is relatively easier than integration, so this becomes the most favorite chapter of all of you, right? So you have to give complete focus over here. The class might go a little longer than the usual Masterstroke sessions, so this will be a one-shot coverage of your chapter Continuity and Differentiability. Pay attention on the screen. Do not be distracted right now. Take your pen and paper, take some water with you, and finish this class alongside me. Once you do that, your chapter will be over. I'll cover up all the important concepts with problem solving, and of course later I'll bring it on with a live where I'll solve the important questions of this chapter, but that will be done later. Right now we'll have to focus on the questions as well as the all concepts of this particular chapter. I have taken some problem solving, but mostly the session will be about your completing one short session of the chapter C and D. I think this is clear now. There's no confusion about it, what we're gonna do. So let's start. So yes, starting with the first thing is continuity. Now before I begin, I have to ask all of you to join us who are watching me for the first time, who have just come across on our channel Deeksha Karnataka, and you are serious about the preparation of your PU2 boards, your KCET, your Comet K. So when you're writing this exam very seriously, you need to prepare also very seriously. And how can you do that? Simply by joining us. How can you join it? Is it any charge, sir? Do we need to pay something to join you guys? Of course not. Just simply subscribe our channel and keep the notification bell always on so that you don't miss any of the classes. And if that is done, of course you will be improving day by day by watching our lectures, by getting the preparation done and getting everything up to the mark. And for the class notes, PDF updates, just you have to do one thing, and that will be joining our WhatsApp channel. The link for that will be given in the video's description. Check that out and join right now if you have not joined yet. Now, yes sir, we are done. You told us about how to join you guys, how to subscribe the channel. That is all done, right? Now let's start the class. Yeah, the class is, as I mentioned, about C and D, continuity and differentiability. Important parts over here. When you talk about KCET, there are a total of 5 to 6 questions. Yes, in KCET, this chapter is worth 5 to 6 marks, and in PU2 this is worth 17 marks. The chapter is worth 17 marks. Now you only decide how important this chapter is. And have you felt this chapter is very easy actually? Yes, it is. So the chapter is easy and worth how much? 6 marks in KCET and 17 marks in PU2. So very crucial. Yeah, so please do not take me lightly when I'm telling you guys that this is going to be important class, and attend till the end of the session. If you're not ready, it's okay. Just take a pen and paper right now, pause it over here, take a pen and paper right now and start solving the questions with me. Start learning the concept and revising the concept one by one with me. Okay, so first thing is, now I can start continuity. Okay, so continuity of a function is what? It talks about the break in the function. Means if there's no break, okay, when you talk about any particular point, let's say the point A, okay, there's no break in the function. Graphically that's what it means, but what it means on paper, on algebraically, is basically finding the limit value. Okay, finding the limit value. And how do you find limit? You have to find the LHL, okay, and you have to find the RHL. Okay, at which point? Let's say at the point x equals to a, and so that this LHL is equals to the RHL, means both the limit value are finite and they're also equal to each other. In that case, what we say? The limit exists. This reminds that the limit exists. Once the limit exists, this should also be equal to the function value at that point. Means limit exists, good sir, but limit should be also equal to the function value at the point A. When that all comes together, then we call the given function is actually a continuous function for the point x equals to a, or at the point x equals to a. Check here. The point where the function is continuous is called as point of continuity. How do you define it? This is your LHL, this is your RHL. They should be both equal and finite and should be equal to f of a. Very simple concept. Now something called as discontinuity at a point. Means, okay sir, I understood the continuity. Means continuity means limit should exist. both LHL RHL, of course, and then should be equal to f of a. So point is continuous. At that point the function is continuous. Then what about discontinuity? When can we call a given function discontinuous? So whatever reason are there to not follow this statement that we mentioned in continuity, one of them, check here, what is this? The LHL or RHL both may not exist. Means the LHL is not finite or RHL is not finite. Okay. Second one, the LHL or RHL both exist but not equal. Means yes, they are both finite. Means this is, let's say, equal to 5, this is equal to 4. They are both finite but they are not equal. It means the limit does not exist. So basically the first two are the reasons where the limit does not exist. Next, check here, the LHL and RHL are both existing in nature and also equal. It means the limit exists, but the value of the limit is not equal to f of a. The limit value that you got, limit of the function f of x when x tends to the point a, is not equal to f of a. In this situation, again, the function will not be continuous. So we got three reasons. First two reasons were based upon limit not existing, means both of these are, either of them are not existing in nature, not finite in nature, and even though when they're both finite but they're not equal, so those two cases are for limit not existing, and the last case is where the limit exists but not equal to the function value. So these are the reasons, or these are the nature of point of discontinuity for any given function. Clear? Okay, sir. Now I want to know in the comment section how many of you already taken the Abhyas KCET test series. I've been asking you guys over all the classes of mine that this is very important, high time to solve KCET questions. After a week or so, after 10-15 days, you will not be able to do that. You have to give complete attention to only boards, and then all 15 days, let's say in the next 15 days or next 20 days, you can solve 5 mock papers, 8 mock papers. Okay, that will be lost. How do you score good in KCET? By solving many mock papers, and this Abhyas KCET test series brings you 31 paid and 4 free mock tests, total of 35. Each will have 60 questions, so calculate the number of questions over there. It brings the coverage of physics, chemistry, maths, and also biology. Alongside that, you also get chapter wise KCET PYQs for the last 10 years, PU2. Yes, and what else you have? You get all of this in the real time KCET exam pattern, means the way you write KCET. Of course, this is the online version of it. This is the online test series. This is not offline test series. If you want to practice OMR sheets, simply download it in the KCET format, start practicing over there, start bubbling, practice over there. That you can do it alongside the online version. But yeah, this is an online test. You get 1 minute to solve a question, and you have a timing constraint as well. So you get to work on both parts, accuracy plus, of course, the most important, speed. Because I understand many of you feel that, sir, I've been preparing for JEE, my subject syllabus is much vaster, much tougher than KCET. But bacha, any exam has its own challenge. The KCET has the challenge of scoring high and scoring faster. JEE mains, JEE advanced, you don't score that high, okay? You get a decent score at around 70%, 60% of marks. But in JEE, so in KCET, it has to go beyond that. It has to go close to 50 out of 60 in the mathematics, because maths is completely easy in your KCET. And even I don't know about the chemistry and physics, but that you can get to know by simply taking the test and start solving the coverage of physics, chemistry, math, biology, all at the price of only 1499. Okay, one of the best test series available for KCET. How can we say that? We at Deeksha have been producing ranks and helping students to get into top colleges of Karnataka for more than 25 years, right? And this team of Deeksha has created this particular test series, not me. Okay, they are very experienced and helping the students for the last 25 years plus. So they are the people behind this test series. They have worked a lot and they have created this particular content, and that's why I'm telling you it's very, very highly recommended by me and by your seniors. You can their names are mentioned over here. You can see, you must have seen their testimonials. So, and more than that, okay, have you not trusted me? Whatever I've done on this platform is to help you out. So if I'm telling you, take this right now, because even one of you misses out it'll be my loss personally. So take this test series and start solving more and more mocks right away, okay? Because to score high in KCET, it requires mock test practice, okay? And that's why the Abhyas comes very handy and very useful. The questions are the most relevant for KCET, okay? Most relevant across, we'll find anywhere. Most relevant questions as per KCET, you'll find in the Abhyas. Next. Okay, sir, coming back to the session, I already took 2 minutes of your time. Forgive me for that, but even that was very important for all of you. So that's why I took your time. Now it's time to go and understand our next topic, which is algebra of continuous function. Okay, so if f and g are two real functions of x which are continuous at the point A, means it's already mentioned that there are two functions f and g, they are both continuous function and they're also continuous at the point A. They mentioned that. Then the sum will be continuous, difference will be continuous, product will be continuous, and the ratio will also be continuous. Even the ratio will also be, a quotient will also be continuous, provided g is not 0, because of course it will become undefined. That is clear, right? So if f and g are both continuous at the point A, their sum, their difference, their product, and the quotient, provided g is not 0 at point A, will become continuous. Okay, now k into f is what? Is k is a scalar quantity, you can multiply to f, that also will remain a continuous only. Okay, if f and g are real functions such that a fog is defined, then what it means is g is continuous at A and f is continuous. It's given that g is continuous at the point A and f is continuous at the point GA, then fog will be continuous at the point what? A. So we have f of g of A na. So g continuous at the point A, f continuous at the point GA, then the fog becomes continuous at the point A. It means that fog is continuous at the point A. Now continuity in the given interval. Okay, continuity in a given interval. So now for intervals we have two types, open and closed. For open there's no problem only. For open intervals there's no problem. It means that at all the points, let's take an example. We have here, let's say -5 and 2. They're both open. They're both open. Means in all the points, how many points are there? Infinite number of points. So at all the points between these two values, -5 and 2, the boundaries, the function should be continuous. Read the statement. Continuity of a function in an open interval is given as a function fx is said to be continuous in an open interval a comma b if it is continuous at every point in the given interval. That's it, a simple thing. But when you incorporate this, when you make them closed, means it includes both the points, both the boundaries, then the story changes. Then it comes into 3 parts. First part same means for the points between these two boundaries, of course it should be continuous everywhere. First point remains same, and at the point -5 we should have which continuity? The right hand limit. The RHL should be equal to f of -5, and at the point 2 the LHL should be equal to f of 2. So at the point A, if you check here, what was A, bacha? A was here and B was here. So at A we go from right, okay, it's called as, at this point we'll go for RHL, and at this point we'll go from left, so we'll find here LHL. Same thing, I've taken the example of what? -5 to 2, no? Check carefully. At -5 I've written what? RHL. You find the RHL and put it equal to f of A, the same point. What is this called as? So now once you talk about a closed interval and you try to define continuity of a function in that, you have 3 points to cover. First point is in every point between those two boundaries the function should be continuous, and the last two would be the RHL should be equal to at the point A f of A, and the LHL should be equal to at the point B, of course, f of B. This is crucial and this is very important, okay guys? You do use it, but sometimes if the question statement changes in KCET, you might make a mistake over there. So got to be clear with this, okay? Because they can ask you in the given interval, which of the interval the given function is continuous. Then you have to check this point, okay? If you know it naturally, good. If not, you got to work on it. Next is some important notes. Check here. A function fx is said to be continuous if it is continuous at each point in its domain. A function which is continuous at entire real line is called as continuous everywhere. A function fx is said to be discontinuous on an interval if it is discontinuous at even one point. Okay, at even one point. Number 4, the set of all the points at which the function is continuous is called as point of or domain of continuity. Clear? Few important points, but I know you all know that. Now I've taken some functions over here and listed down their interval of or their domains of continuity. Check here. Constant function, continuous everywhere, so all real. Identity function, also continuous everywhere. Polynomial function, also continuous everywhere, also continuous everywhere. Now if you move on to rational function, which is px by qx, everywhere except for when qx is 0. Okay, when qx is 0 it will become undefined, right? Modulus function, again continuous everywhere. It's continuity, not differentiability. Okay, it's not differentiable at the point 0, but usually continuous, yeah, always continuous everywhere. X bar minus n, it's again rational function form, so you get here also continuous except for the point 0. Next, sin x cos x e power x, continuous everywhere. If you're not sure, draw the graph of sin x cos x and e power x, you'll see that continuous everywhere, there's no break in the graph. Tan x secant x, except for the multiples of pi by 2, remove the odd multiples of pi by 2, odd multiples of pi by 2. So except for these points, everywhere continuous. Okay, because there it becomes undefined, right? Cot cosec, the multiples of pi. Here we have multiples of pi. Okay, what type of multiples? Integral multiples. Integral multiples of pi, the given function will be not continuous because they'll tend to what? Infinity. That's why they have removed r minus, you can see there. Log x only defined for what? Positive side, so 0 to infinity. ITF in the respective domains, because over here what happens in the case of ITF, no, there's a truncation actually. You're gonna truncate the function, right, to get the inverse true. Composite functions, we have learned about this. You have to define g at at x and f at ga, then Fogg defines at a continuous at the point a. Okay, now we are moving to the differentiability. So from the continuity question comes in both, there's a 4 marker that comes in your straightforward section E, okay, and there's a question that comes in MCQs also. But if you talk about KCET in continuity, the question can come, they can ask you a missing variable, same way, the way they ask the 4 marker, no, in PU2, same way they ask a limit based questions for continuity. Okay, and they ask you to find the missing variable. Okay, that is one question that comes, 1 marker if it comes. Differentiability, the question that is coming in your PU2 are, like, the chances of question coming in PU2 are less. So if you take the last 10 years, maybe 2 or 3 times they've asked questions in differentiability, means proving the differentiability of a given function. They have asked once where they gave you 4 equations. You use both there, continuity and differentiability, but chances, if you see, only 3 times to 4 times they have asked in last 10 years. If you include that also, when they asked with continuity and differentiability together, then it becomes 3 to 4, otherwise only 2 to 3 times. Okay, that's for differentiability chapter in PU2 wise, but for that's for PU2 wise, but for your KCET, the question can come from here. They can ask you to prove differentiability of modulus function and different categories over there, but you don't use the first principle over in the case of KCET because there's no point of doing that. But here we'll learn the differentiability with the help of first principle only. What is that? F dash of a function at point C is called as f of x minus c upon x minus c. Okay, and we have of course both the rules. This is the limit that we find. We replace it with, when you go from the RHS side, you replace x with c plus h, and go from the LHS side, it's called as c minus h. If you remember, I'm talking about this particular case. This is your RHD, and the next one will be your LHD, left hand derivative. Check here. Check here for RHD, this x is replaced by what? X plus or c plus h, because the point is c over here, no, it will become c plus h. See, f of c plus h minus f of c divided by h. This is the limit, which is going to be what? This is going to be the definition of your RHD. And for LHD, it will become c minus h minus f of c upon minus h. This is your LHD. from the first principle, and for the given function to be differentiable, for fx to be what? Differentiable at the point x equals to c, then this LHD should be equal to what? RHD. Means basically both of the limits should exist finitely and they should be equal in nature. Then only you can say that the given function is what? The given function is differentiable at the point C. Again, yes, this is the right way to do it, but in the questions of KCET we don't need the steps. So you usually follow the trend of redefining the function and differentiating at the different intervals and then comparing it. We use that more often, okay? But here, if you go by the method definition, this is the result given to all of you. Do not forget to check the notes out. How can you do that? WhatsApp will share it. You can go and join and collect the notes, okay? Collect the PDFs. All right. So notes, a function is said to be differentiable at function if it is differentiable at every point in its domain. A function is differentiable at each x belongs to R, then it's called as differentiable everywhere, of course. Moving on. Relation between continuity and differentiability, very simple. A given function which is differentiable will be always continuous. Okay. Now if it is non-differentiable, it may or may not be. Okay. Means I can take example over here. This is a modulus function. Differentiable, sir? No. Continuous? Yes. Okay. So the given function which is differentiable will have to be continuous, and a given function which is not differentiable may or may not be continuous depending upon the type of function, okay? If there's a break in the function, let's go like this, okay? This function over here is not continuous and it's also non-differentiable. So this function is non-differentiable but continuous. Differentiable, no. Continuous, S. Here differentiable, no. Continuous also, no. So the continuity, we cannot say anything just because of the differentiability not existing, but if it is differentiable, then always will be continuous only. Next, a function which is continuous may or may not be differentiable. We cannot say the same way. This one you can check, continuous but not differentiable. Fourth one, a function which is discontinuous has to be differentiable. If it is discontinuous, it has to be, not differentiable, I meant non, my bad, not differentiable, same thing. Break is there, it's not continuous and not differentiable. So basically two summary. If it is differentiable, it will be continuous, okay? If it is discontinuous, it will be non-differentiable. Repeat after me right now, because I know there's confusion right now, okay? Let's clear it up with me. Repeat after me. If it is differentiable, it will be continuous. If it is discontinuous, second point, if it is discontinuous, it will be non-differentiable. Okay, clear, sir? Next, f dash of a minus 0 is a finite number, then fx is continuous at the point a from left hand side. A finite left hand derivative implies that the left hand limit of the function equals the function value at the point. Okay, same way, what is this? This is your right hand limit, okay? So this will be a finite right hand limit. Check here, this is a finite right hand derivative. If it is defined, it means that the function is what? A function is going to be continuous from the point x equals to a at the point from the right hand side. Yes. Moving on, differentiability in an interval. Again, so we have two cases, one is closed, one is open. Yes, fx is differentiable at the point a from the right hand side, and this is what is it going to be? This is your RHD, okay? And fx is differentiable at the point b. This is called your LHD for the interval a comma b closed, okay? And of course at every point should be differentiable from both the sides. Means at every point it should be differentiable basically, okay? And a function fx is said to be differentiable in any open interval. This was closed interval, this is open interval. Again, only for this one. At all the points, it should be differentiable from the both sides. I'll repeat. For open interval, same case. At all the points, it should be differentiable. And for closed interval, it has the case, of course, this continues. Means at all the points between the two boundaries, it should be differentiable. And at the point A, you should have RHD. And at the point B, you should have LHD equal to the value existing in nature. Not equal, sorry. That is for continuity, right? That's not, yeah, my bad. Moving on, derivative formulas now. So this is the end of your differentiability, the conditions of differentiability, and how to solve the questions on that. So this is where one questions from so far we have covered 2 questions in KCET and 1 question. Yes, both topic will have one question each. Yeah, total 6 question comes, and the first 2 questions will be from first 2 topics in KCET. That's there, pakka. But for your what do you call, for your PU2, so far only 1 question might come, okay, but from here onwards PU2 will have many questions. Derivative formulas and derivative basics, many questions are there in MCQs. There are total of 3 MCQs, 3 1 marker, which is coming in your PU2 as per the latest blueprint. So very important. Let's look at the first formula that we have, polynomial function. Yes, if it's given like this, a times of x power n, derivative is given by a n, the n comes in front, and x power n minus 1. If you have functions exponential and logarithmic, I have listed on the formulas. E power x remains as e power x, a power x becomes a power x ln a, ln x becomes 1 by x, okay, and log of x with the base a becomes 1 by x ln a, 1 by x ln a. Next, trigonometric functions. If you see, we have 6 functions, 6 ratios over here, and the respective derivative over there. This is your f of x, this is your f dash of x. Sine is cos, cos is minus sine, tan is sec square, cot is minus cosec square, sec is sec x tan x, and cosec is minus cosec x minus cot x. Yes sir. Now some differentiation rules or theorems. First one is, if you differentiate a constant, answer will be always 0. If you are differentiating a constant multiplied to a function, remove the constant to be outside as a coefficient and differentiate the function. First 2, very simple, very basic rule. I know all of you know that, but still let's revise everything that is there, and very important, because many of us make silly mistakes and we cannot have that. Okay, that's something that I don't like at all in any of my students. If you're making silly mistakes, it means that you know something, still you make mistake in it. That's why I'm revising one last time in one shot video the entire chapter C and D. Okay, as I mentioned in the beginning, stay till the end to cover up everything, all the concepts alongside the questions also. I've taken questions that will come, don't worry, but be aware of your situation right now. You cannot miss marks. You cannot miss marks because of the silliness that that you've not revised properly. You missed out on something because you thought you are good at it, but still sit back with me, revise it, and of course the chances of making mistake reduces once you do that. Okay, next. Yes sir, enough talking, let's get back to the session now. Product rule is going like this. You have 2 functions fx gx, keep one as it is, differentiate the other, and gx as it is, differentiate the f. Preference in the product rule is not there. You can take any of them as the first derivative and keep the other one as it is. So there's no preference in the product rule, no preference. But when it comes to your quotient rule, the things changes. Okay, so if you have 3 functions f, g and b, you can keep the derivative of fx first, keeping the other 2 as it is, differentiate g, other 2 as it is, and differentiate b, other 2 as it is. No preference order. But in case of quotient, the preference is there. Preference is given to what? The numerator. You got to differentiate numerator first. This is your numerator, check here, f by g. F you differentiate, g keep as it is, next comes a minus sign. Here we had a plus sign everywhere, plus, okay, here it is a minus sign. So first you differentiate f, keeping g as it is. Now you differentiate g, keeping f as it is with a minus sign, and divide by the denominator square. Yeah. Now the chain rule. Okay, and of course I've given you a trick for this one, I remember, right? What's the trick for this? If you have a function like this, let's say ax plus d, and you have, what is this, cx plus d. The value of this derivative is given by, check this out guys, a b c d determinant divided by cx plus d the whole square. Cx plus d the whole square. Please check once. Okay, this is one trick which is applicable. You can write this as function fx also, but usually this is for this kind of condition, ax plus b upon cx plus d. The derivative will be given by a b c d, the determinant by cx plus d the whole square. Moving on, chain rule. Now this is a very simple concept. If you have a function, let's say function y is there in terms of u and function u is in terms of x, then you're going to differentiate y in terms of x, right? You have to differentiate u with y with u and then u with x. Okay, same way, y is a function of u a function of v is a function of x. So differentiate y with u, then u with v and v with x, because you have first with y with u with v and v with x. That's the rule of chain. You'll see in the questions, don't worry. Now this is the case of implicit function, because whenever you can't make a subject of y directly, this is the case of implicit function. Implicit function. So this is a concept which comes usually in your PU2, but not that every year it comes, but sometime it keep coming. Let's say last 10 years you'll find it 4 to 5 times. This is there, so not that less important. Okay, how to solve it without thinking of anything? Just solve the entire equation at the same time. Okay, over here you'll get 2 sine y. How come, sir? Derivative of polynomial 2 sine y, and differentiate sine y next. You'll get what? Cos y. Is it over now? No. First we are looking for what? We are looking for dy by dx. It means I have to differentiate this whole function or whole equation with respect to what variable? With the x variable. So first you did for the power 2, which is nothing but your polynomial. First you did for this one. This is polynomial. Then you did for sine y. That is your trigonometry. And then you're going to do what? Y again. It will be polynomial one more time. Okay, getting it? So you'll have to differentiate y also. You'll get dy by dx. Over here you're going to differentiate cos. So you'll get cos as minus sine xy. Is it over? Of course not, because you have to apply chain rule for xy, and xy is a product of two functions x and y, so you'll have to apply product rule. So x will be 1, y will be as it is, x as it is. You'll have dy by dx. Pi is a constant, so 0. Okay, great, sir. Take 2 sine y cos y. It will become sine 2y. I can represent it like this only. Sine 2y. This is nothing but sine 2y dy by dx. Okay, over here what I have is minus y sine xy, and over here what I have a minus x sine xy dy by dx equals to 0. So combine the terms with the dy by dx. Yes, and the other term on the other side. Move this term on this side of the equal to sign. If you combine and take common, you'll get dy by dx is common. Here you have sine 2y with a minus x sine xy, and over here you get equals to y sine xy. Y sine xy. Now move this bracket over here, you get the result. Derivative is given by y sine xy divided upon as sine 2y minus x sine y. Sine 2y minus x sine y is your answer. Okay, this particular case uses your product rule. This is the chain rule, right? This is the chain rule, use of chain rule, use of chain rule, use of product rule, and of course anything else. That's it. Yeah. So yeah, use of both the rules is there in this particular question, and this is a case of implicit function, of course. Next, again we have x equals to cos xy. Find the derivative. How are you going to solve it? Same result. Take here, x will be 1 derivative, cos will be what? Minus sine of xy. Inside you have to do the for x and y. X is 1, y is dy by dx plus x is as it is. Okay, my bad, I did both together. So I'll keep x as it is first, and y is dy by dx. Next I'll keep x as 1. 1 second. X as 1 into y. Am I right? That's correct, no? Check here. So I differentiated x as 1, cos becomes minus sine of xy, and then you differentiate this xy, you get x as it is dy by dx, and then you differentiate x, you get 1 and y. Expand it, you'll end up with what? Minus sine xy times of x dy by dx plus, sorry, minus again, minus y sine xy minus y sine xy. Move on this side, you'll get 1 plus y sine xy, and this is nothing but minus x sine xy dy by dx. I'm looking for derivative only, so I'll move this whole over here. I get minus 1 plus y sine y upon x sine xy, and this is equals to what? My derivative. Check my derivative. So minus 1 plus y sine xy, my sine xy, sorry, 1 second, y sine xy and x sine xy. So answer is option A. Okay, so this is a question like which you can expect in your KCET examination. Application of what? Your chain rule, product rule together. Moving on. This one. Okay, how would you solve this question? A very simple one. Check this out and let me know. So if I take this as my question number 3, right? 1, 2 and 3. Question number 3 answer I want in the comment section. Comment below. Let me know what is the answer for question number 3. You can let me know the option. Okay, let me know the option. Yeah, you can do 2 ways. Simply differentiate it like this only, or you can take this on the other side and square it on both sides and then differentiate. Bring this over here and then square it up. You'll get x square 1 plus y. You'll get what? This value as y square 1 plus x, and then differentiate. Your choice. Give me the answer for the question number 3. Next, if you have 1 minus cos x upon 1 plus cos x in the root, derivative you have to find out. Looks a difficult question, but not it is. It's not actually a difficult question. 1 minus cos, the formula you should all know is 2 sine square x by 2. Yes, 1 minus cos is 2 sine square x by 2, and 1 plus cos is 2 cos square x by 2. 2 and 2 is cancelled. I get sine x by 2 upon cos x by 2 the whole square. This becomes what? Tan square x by 2. Apply root now. We get root and square cancels. You have the answer as tan x by 2. Check the result. What you have so far is basically y equals to tan x by 2. So y dash will become what? Secant square x by 2. That's just for derivative of tan. You got to differentiate x by 2 also. So you'll have the answer as 1 by 2. My answer is 1 by 2 secant square x by 2. So option A is correct. Option A is correct. Clear, sir? Clear? Superb. Have a look. Next what? Derivative of inverse trigonometric function. Again, the 6 we have ITFs. Sine inverse derivative will be what? If this is my f of x, this value is f dash of x. Sine inverse is given as 1 upon root of 1 minus x square. Cos inverse is with the same thing as a minus sign. Tan inverse is 1 upon 1 plus x square, and cot inverse is same thing with the minus sign. Same goes over here. Sec inverse is 1 upon x times of x square minus 1 in the root, and cosec inverse is same thing with the minus sign. As simple as that. Okay, so remember sine, you get cos inverse. Remember tan inverse, you get cot inverse, and you get, remember sec inverse, you get cosec inverse. Out of these 3 are the most relevant and most useful, most occurring. Okay, most occurring in questions in PYQs. If you check the PYQs, no, these are the 3 which is always coming in the questions. Okay, but these 6 are very not difficult ones. You can just go through it and remember all the 6 ITFs derivatives. Next, yes, a question on cos inverse now. Okay, ITF is there. Okay, this is something, a formula. Take x as tan theta. It means the theta value is what? Tan inverse of x. Tan inverse of x. So if you check here carefully, it becomes what? 2 tan theta divided by 1 plus tan square, and it becomes what? This one becomes your sine 2 theta. This is the formula for sine 2 theta. The question is transformed now. Y equal to cos inverse of sine 2 theta. Sine 2 theta. Okay. Now check. I know we have outside cos inverse and inside we have sine inverse. I can write this as, check this out, cos of pi by 2 minus 2 theta. Pi by 2 minus 2 theta. Sine of 2 theta is same as cos of pi by 2 minus 2 theta. Yes. Now apply the cos inverse on this. You'll get the answer as pi by 2 minus 2 theta as y. Now differentiate. You'll get y dash as pi by 2 minus is there, yes. So we get y dash as 0 minus 2 times of tan inverse of x the derivative. You get the answer as y dash equals to minus 2 upon 1 plus x square. Clear? Moving on now. Yes, exponential functions. Now we'll look at some of the common functions which is extensively used in C&D and entire calculus. So what is this going to be? Very simple. We have two categories over here, one with the base E, one with the base A. Okay, when the base is A, is like simply a standard exponential function, but when you make the base to be E, this is called as natural base. This is with the natural base. The value of E is close to 2.7, okay, 67. In the base of exponential function, if it is E, then it becomes what? A natural exponential function. When it is not E, 10, it becomes a common exponential function. When the base is 10, not E, it's a common exponential function. And we can have other bases also. We can have base 2, 5, anything. But usually we use 10 and E. For E you get natural exponential function. For 10 you get common exponential function. I have given the formulas for both the derivative if you remember. Okay. Now features of exponential function. The features is very simple. If you have this for the graph where the base lies between from where to where? From 0 to 1. When the base lies from 0 to 1, the graph goes like this, means it is a decreasing in nature, decreasing function in nature. But when you make this, basically a value is more than 1, or then the graph changes to this. This will be same as this point will be same as 0, 1. It will not change, but this is your graph for a value more than 1 for the function a power x. Now think logically. If I ask you to draw and choose the graph for e power x, will it be this one or this one? It will be of course this one, because e value is more than 1. So not the other way around. This is not true. The graph of ex will look something like this. The graph of ex will look something like this. Okay. So when you go to negative infinity, the value goes to 10 to 0, and then you go to plus infinity, the value goes to what? Plus infinity only, this on this side. When x goes to plus infinity, y also goes to plus infinity on the right hand side. Okay, the domain is all real, range is only positive values, not even 0. Check here, only positive real number, not even 0. The graph I have drawn for both of them passes through the point 0, 1 in both the cases. For a very large negative value x and a more than 1, the negative value, the function goes to very close to x-axis. Negative value I'm talking about, negative value of x over here you can check. It goes close to the y-axis, sorry, x-axis, but never touches it. Okay, but never touches it. The x-axis never reaches the 0 value. Now we have similar to this, of course, the inverse of exponential function, which is called as logarithmic function. So you just simply take log on this exponential condition. It becomes what? Log of x over here, and you get this as a to the, what is this going to be? Log of, okay, sorry, my bad. This will be what? Log of x becomes log of b with the base a. Log of b with the base a will be your value of x. So these are your inverse forms. Okay, transformation of this to this will be given by that. So basic understanding is the base remains same. Here the base is also a. Here the base of exponential function is also a. The base of exponential function is a. The base of logarithmic function is also a only. Clear. The function forms the again the graph. If you check, the graph is very clear. We have two cases. One goes like this, another one goes like this. The point remains same. The point is 0, 1. Log is always, sorry, not 0, 1, 1, 0. My bad. Log is always 0 when the point is 1. This is the case of what? When the value of a is more than 1, and this is the case for value of a being between 0 and 1. So if you talk about ln, okay, this is your log of x with the base a. This is your same thing, log of x with the base a. So ln x will form something like this. Okay, and never goes on the left of y-axis. There's no negative value allowed in the log. So log cannot be found for negative values. Clear? When the base is a is called as common log. When the base is e is called as natural log and written as, so log with the base, excuse me, log of x with the base a is common log. But when you change this to e, this becomes natural log ln x. Clear? Got it? So usually in your syllabus we're dealing with only this particular case. When they're mentioning something else, so even if they say log of x, they mean the same thing. If they want some other basis, they'll write it there on purpose, okay? Otherwise, if they mention ln x or log x, they mean the same thing as the base is natural value e. Okay, clear? So domain and range is clear. Domain is all positive values, not zero, and range is all real values. Check here, domain is all positive and range is all real, which makes sense. This is the inverse of your logarithms. Domain all real, range positive. Here we have range all real, domain positive. Okay, they're inverse of each other. Makes sense. Yeah, features, I've already drawn the graphs. All these values are mentioned already there. Okay, I'm going to move on from here. Now, basic properties. The formulas are very important. This is the product rule. When you have nm, you can separate the logs, log of m plus log of n. Why this I'm taking over here? Because there are a lot of questions, even 3 marker, that comes on logarithmic differentiations. So this is very, very crucial for your PU2 especially. And of course, in KCET, many questions on the principle of logarithms are there. Log of x with the base a can be written as, you can just keep taking the bases like this, e over here, e, and I can keep proceeding, okay? I'll have e, b, c, c like that. Basically understanding is the first base should be this and this should be always x. You can have as many expansions as possible, okay? Now you go to this, what do you call? Quotient rule. It becomes log of m minus log of n with the same base a. Now, if you have the coefficient comes in the front of log, so power comes as the coefficient of the log and log a power m. Okay, e power log e will be simply x, because e and logs are both what? Both inverse function, provided that this is also with the same base e. Okay, clear, sir? Now, anything else that is there which is important in the properties of log? That's it. Yeah, if I have log of, let's say, a with the base b, I can write this as log a by log b with the same base, of course. With the same base, I can write here mm, of course. This is also a property. Okay, I'll write it again and clear. 1 second. Log of a with the base b is there. No, I can write this log of a with the base m, log of b with the base m. One property is there. Now one more I wanted to write. Log of a power m is there and b power n is there in the base and the value. Okay, so log of a power m with the base b power n is nothing but this m comes in front in the coefficient of log, but comes in the numerator actually, and this will come in the denominator. So this power comes in denominator and this comes in the numerator, so it becomes m by n log of a with the base b. They are useful in the KCET problems, that's why I'm writing over here. Be careful, you got to remember these properties, very, very important. Okay, I think I've mentioned some over there. No, I've not. But yeah, check here. We can change this log of x with the base something with the same basis, log x by log a. Okay, you can change this value of m to n to n to m by taking the reciprocal. So basically, log of a to b and log of b to a is always 1. Log of a to b to log of b to a is always 1. Okay, log of a to a is also always 1. Log a with the base a is always 1. Now if somebody says that, sir, then what happens to this? Log of 0 with the base 0 is 1. No, log with the base 0 is not defined only. And remember, log is not defined for what? For the 0 value. Check the graph. The graph never touches the x-axis, sorry, the y-axis. It means x is never 0. And what about this? This base is never 0. This base is never 0. Even x is never 0. So somebody who tells you that log 0 with the base 0 is 1, that's not correct, okay? That's not correct, because it is not part of the definition of log itself. The domain is not sustainable, it's not provided over there. Okay, you got to check that for this value is true only for the values where the log is defined. The domain should be true, okay? Alright, so log of 1 is always 0 with any base you take. Log of e with the base e is also 1, okay? Derivative of log, I have already given that. If a function is fx given over here, take this as denominator, and derivative of fx will be f dash of x. F dash of x, okay? Great. If you have e power fx, differentiate it as, so e power fx as it is, then differentiate f of x again, okay, and so on. If you have a power fx, keep it like this and then put ln a or log of a and then differentiate f of x, okay. This is the basic application of chain rule after derivative of a power fx. Remember, I taught this formula. A power x derivative is what? A power x ln a, okay, and derivative of x is what? 1. Same thing they've written here. Instead of x we have f, so they've written the derivative of f. Nothing changes. Moving on, some questions on this is chain rule with exponential functions. So first apply derivative for sine, then you're going to go and differentiate sine inverse, that's a tan inverse, and then differentiate e power minus x. We'll see. Function is y equal to sine of tan inverse of e power minus x. So first you're going to differentiate what? Sine. So you'll get cos of tan inverse of e power minus x. Now what is the next one? This is the first derivative of first function. Then you're going to go to inverse, ITF. For tan inverse you'll get what? 1 upon 1 plus x square, whatever the value over here, to the square. E power minus x the square. Now you're going to differentiate what? E power minus x. That'll be what? E power minus x the derivative. I'm going to do that in next step if you don't mind. Yes. So let's simplify this. You'll get cos of tan e power minus x, tan inverse actually, and write it over here. 1 plus e power square is there, means minus 2x. I can use the product rule, the power rule, right? Power to power gets multiplied. So minus x into 2 is minus 2x. Okay. What about this? Differentiate this one. You'll get e power minus x as it is. Now differentiate minus x, you get minus 1. My answer is basically minus e power minus x cos of tan inverse of e power minus x divided by 1 plus e power minus 2x. This is my answer for y dash or y1 derivative. Good question. Combination of course chain rule, then you have for different functions, trigonometric, inverse trigonometric, and also exponential. Please check. Next, differentiate e bar x log of sine 2x. This is a product rule question. So I'll keep derivative of e power x, so it will become simply e power x, and the other one as it is, so log of sine 2x as it is. Now differentiate. Next step, keeping e power x as it is, differentiate log, so you'll get 1 by sine 2x. Differentiate sine now, you'll get cos 2x, and differentiate 2x, you'll get 2. Take e power x common, you have log of sine 2x, 2 times of cos by sine, so 2 cot 2x. Check here. E power x, 2 cot 2x, and log sine 2x. Okay, option B is correct. A is only cot x. You got to write cot 2x. Cos 2x by sine 2x is cot 2x. Next. Now this is the most important topic from here onwards in the C&D, which comes for 3 marks actually, and many of you lose this or don't solve it in the examination because of the complexity nature of the particular problem. Okay, so what happens over here, you have 3 types of question that comes. Either the function form is f power g, or f into g, or f by g. Any of the form is given. Our job is to take what? Logs on both sides. So write this equal to y, y, and y. Take logs on both sides and then start the differentiation. Y equal to f of x gx is there, no? Take log on both sides. This gx will come as the coefficient. So log y equal to gx log of fx. Now use the product rule. I'll show you. You'll get for log y, check here, 1 by y. That is derivative of log. Derivative of y will be what? dy by dx. Differentiate gx, you'll get gx derivative as g dash, and then keep log of f as it is. First step. Then add plus sign, and this time keep g as it is and differentiate log. You'll get 1 by f, and into f dash will come. Okay, check carefully. You're getting here g dash ln f plus g by f dash, g by f dash, and move y on this side. You'll get y over here, and that's my answer. Y g dash ln of f plus g by f dash is the derivative of dy by dx for the function. There's a dy by dx for the function f power g. Okay, f power g. Now if you want, this is the log application, this is the application of quotient. You can try this, and when you try this method, you'll get the same result. Try and let me know. You'll get the same result if you apply the condition for exponential functions, right? Here you have a condition for logarithmic function. Check here, I've taken here exponential function as the base. If you take e power gx and log, what happens? This will come over here, right? Correct, no? Yeah, same thing. Next, a question on the same property of logarithmic differentiation. Take this y as cos x, cos 2x and cos 3x. What is the first step I mentioned? Take log on both sides. Log y. When you take log of this, what is the formula for log of ABC? Log of ABC formula is log A, log B and log C. Formula is log A, log B and log C. So log of cos x plus log of cos 2x plus log of cos 3x. Now you differentiate. You get here 1 by y dy by dx. Over here you'll get what? Log of cos x. So you'll get 1 by cos x. Differentiate cos, you get minus sin x. Minus sin x. Same thing, minus sin you'll get over here also. Cos 2x comes over here, differentiate cos. You're gonna get what? Minus sin 2x. So you'll have 2 also. Minus 2 sin 2x. Differentiate and let me know. Derivative of cos 2x is what? Minus sin 2x into 2. I've written here minus 2 sin 2x. Same way over here. Minus 3 sin 3x by cos 3x. Check. You have minus sign common. And over here you have what? Tan of x, 2 tan 2x and 3 tan 3x. Okay. Now if you check, you have the answer. Over here you have 1 by y dy by dx. Move on this side, you'll end up with dy by dx equals to minus y times of the same thing repeats. Same thing repeats. So what is going to do the value of y? Same, cos x, cos 2x, cos 3x. This kind of question comes actually. Okay, very important. 3 marker. This is how it comes in 3 marks. Now, interesting question. You have to find differentiation. Looks very simple. Let's try to find it out. Y dash log is there means 1 by tan will come. 1 by tan x by 2. Is it over? No. You have to apply the chain rule. For that, you're going to get derivative of tan as secant square x by 2. And you differentiate x by 2 also, you get 1 by 2. You get 1 by 2. Now simplify this. You have 1 by 2. Tan becomes sin x by 2 by cos x by 2. And what is going to be sec square? 1 upon cos square x by 2. Correct? This and this is cancelled. One of the squares. You have 1 by 2 sin x by 2 cos x by 2. Answer is what? Check here. 1 by 2 sin x by 2 cos x by 2 is simply sin 2 times of x by 2. 2 cancels. 1 by sin x. How much is that? Cosec x. Cosec x. Answer is option C. A simple question as I mentioned. Come on. Yes. Next. Differentiate e power log x log 3x. A difficult one? No. Check here. E and log with the same base, they are inverse to each other. We have only log x left with log 3x. And this is your function y. Differentiate. You can treat them differently. Okay, y you can keep this as it is and differentiate that. So keep log x as it is. Differentiate this. You'll get 1 upon 3x into 3. And go ahead right here plus. And this time differentiate this. You're gonna get 1 by x log 3x. Log 3x. Okay. Excuse me. 1 by 3x and yeah, correct. So this 3 and 3 is cancelled. Here 1 by x also cancelled. Check this out. 1 by x is common. You get log of x plus log of 3x. Log a plus log b is what? Log of a into b. So x into 3x. Answer is 1 by x log 3x square. 1 by x log 3x square. B looks right. B looks correct. Please check. Yeah. Next. Moving on. Next. E power x. Direct answer is there. Integrate. Sorry. differentiate this e first, remains as it is, e power x. Differentiate this now, you'll get e power x. Answer is option A. Right answer. Chain rule. Nothing else is there. Okay, next. Derivative of the function in parametric form means when the two functions are given, function x in form of variable t and y in form of variable t. The t is the parameter over here. The t is the parameter over here. How do you find dy by dx? So to find dy by dx, what you do is basically you find dy by dt and dx by dt. So this would be dx by dt and get the ratio. So dy by dt divided by dx by dt. Take the ratio to get the value of dy by dx. This is your case of parametric form derivative. Sometimes this parametric form actually becomes to what? Function to function. Differentiate one function with respect to another function. Check here. Same thing. Function with function. What do you do in this case? Differentiate. If you have, let's say, dy by dx to find out, you're going to differentiate f dash by g dash. See here, y derivative upon z derivative, where y is fx and z is gx. Nothing difficult over here, nothing different over here. I'll show you. Okay, check this out. This is a parametric form. This is a function only. Okay, check. I'm looking for dy by dx, right? I'll get this as derivative of a. So dy by dt I'll get for this numerator. I'll get here dx by dt. So first part is very simple. dy by dt is very simple. A cos t. A sign will be cos t. A is a constant. Okay, my bad. This is not dx. This is dt. What about dx by dt? Check. For this you'll have to differentiate like this. Keep a outside. Derivative of cos will be what? Minus sine t. Okay, then you get plus over here. And log is there. If you remember, this was coming as 1 by sine t. Log of t by 2 was coming as, log of t by 2 simply is coming as cosec. If I take this as t by 2, it becomes cosec t or 1 by sine t. Yeah, same way over here. If I have t by 2, it will become what? 1 by sine t. Combine them. You get here sine square t plus 1 by sine t. You get here a cos square t by sine t. Okay, now take the ratio. First one is a cos t and this one is a cos square t by sine t. A cancels, cos t will cancel this one and the sine t goes up. Answer is coming as sine t upon cos t, which is nothing but tan t. Answer is dy by dx as tan t. Straightforward question which is using what? Parametric form. Parametric form. Now again this question now. This is a derivative of a function with respect to another function. Okay. So differentiate this. I'll take this function to be, let's say, p and this to be function q. What are they asking? Find dp by dq. You find dp by dx over here and dq by dx and take the ratio. Take the ratio. Okay. Differentiate p first. Check here. Nothing is different. 1 by log. So log is there, no? 1 upon 1 plus x square will come. And derivative of this also will be there for the chain rule. You'll get 2x. And if you take dq by dx, tan inverse will become simply 1 upon 1 plus x square. I'm looking for the ratios. I'm looking for their ratios. So this is cancelled. Answer is coming as simply 2x. And this is the value of your dy by dx. Option C is correct. Got it? Yes. Next. And the last and important concept is your second order derivative. One question guaranteed comes over here in 5 marks. PU2, 5 marks. A question will come from here, and even in your one question will come in the this is your in the KCET side. KCET also comes to 1 mark question. One question comes from here. Okay, 1 in PU2, 1 in KCET is guaranteed. Okay, but PU2 has 5 marks worth, KCET has only 1 marks worth, but equally important and easy concept. What is this? Derivative of first derivative is called a second derivative. Check here. Derivative of first derivative is called as second derivative. That's all, nothing else is there. You represent it like this as first derivative f dash x, so f double dash as your second derivative, dy by dx is first, then second derivative will be d square y upon dx square. If this is y1, the other one becomes y2, and that's all. Okay, and that's all. All right, so if I take an example over here only, if my dy by dx value is given as 2x, what is my second derivative, sir? It will be d by dx of dy by dx, and answer becomes d by dx of 2x. What is the answer? Simply 2. That's the value of my second derivative in this particular question. I show you over here. What is the answer for this one? Tan t. If my dy by dx is this, my d square y by dx square will become what? Check this out. This will become, sir, secant square t dt by dx. You have to apply chain rule, right? Tan t is your dy by dx. Differentiate, you get secant square t by, that is correct, but differentiate dt by dx also, and don't worry, you have that value. Dx by dt is over here. Just take the reciprocal from here. Take the reciprocal and write it over this. Again, this is the extra information. This all is extra information. Extra information for the second derivative. But I hope you're getting the point, right? And that's how the questions are going to be. I did not say that just because it comes for 5 marks it's going to be difficult. It's very easy. Very easy concept, okay? So this is going to be the end of your lecture in the CND, your master stroke. I know it feels easy, it feels very short, but yes, I have covered every single concept which is there in your chapter, alongside the question, alongside your different topics, the number of questions that comes, number of marks that is worth in different basically in PU2 and KCET examination, not different examination. So in PU2 what question comes, in KCET what questions comes. I've given all the informations, okay? If you want anything else from me in this particular chapter, let me know. If I missed something, let me know as well. What you can do is simply give me answers and queries in the comment section. And I hope you have all subscribed to our channel so far. If you have not, then you're gonna miss out on a lot of classes that we have planned for all of you, and simply it will affect your marks. What you can do is simply join our channel right now and start attending all the classes. Everyone is very important. Okay, we are working really hard over here. You can see how much effort we are putting in to make sure that you are, nothing is left out, nothing is left to chance, and we are here to deliver everything on time with the best, thinking in the mind that we'll get the best output. And subscribe to our channel, join our WhatsApp community to get all the PDFs, all the updates. That's all for in this class, okay? And of course many more to come. See you in the next class. Till then, take care. Bye bye.